Hello, ladies and gentlemen, and welcome back. We're going to continue our look at the 2004 Gauss paper with question number 23. It takes Sharon 1 hour to drive the 59 kilometers from her home to her office. So she's doing 59 kilometers an hour if she's doing it all evenly. Okay. Her drive includes 20 minutes on a highway and 40 minutes on city roads, so maybe she's not driving an even speed. If her average speed when she is on city roads is 45 kilometers an hour, the average speed in kilometers per hour at which she drives on the highway is... okay. So, for this question, we're going to have to make use of the fact of a nice physics formula that you can express distance, speed, and time, average speed, by the way, in one nice equation. So you can tell the distance that you traveled if you know the speed and how long it took. Or you can figure out the average speed if you know the distance you traveled in how much time. So what we're going to do for this question is we have the time that she was on the highway. We don't have the speed that she was on the highway. We have the time that she was on the city roads, and we have the speed that she was on the city roads. So combining those two, time she was on the city roads and speed she was on the city roads, we can figure out the distance she traveled on the city roads. Okay? From that distance, we know the total distance. What's left over? The distance that she went on the highway. Then we'll know distance on the highway, time spent on the highway, and from there we can get speed on the highway. Okay, so that's our plan of attack. And it all uses this formula right here. Distance is speed times time. Okay, and this can be rearranged as you need it. I often remember it this way. DST, they start to go top down and left to right in alphabetical order. And so distance is speed times time. So if we wanted distance, we just cover it up, speed times time. If you wanted the time it took, but you knew the distance and the speed, don't know what I'm drawing that for. If you wanted the time it took, but you knew the distance and speed, you would fill this in and cover up the the T. And so time is distance over speed. There's a bunch of these I learned in my high school physics class. There's another one. Mass is density times volume. Mass over volume is density. Volume is mass over density. There's a couple others. But we're interested in the distance, speed, and time relationship. Okay. So we were given some numbers. Now everything's in kilometers and hours. So the first thing I'm actually going to do is change 20 minutes into 1/3 of an hour and 40 minutes into 2/3 of an hour. Okay. So 20 minutes times 1 hour per 60 minutes. You'll see everything sort of cancels out and you'll get 1/3 of an hour. Similarly, 40 minutes is 2/3 of an hour. Okay? So now we'll have the right units. Kilometers an hour and then kilometers per hour. Okay, so Sharon's distance on I think it's city roads. I'll check that in a second. Sharon's distance on the city roads, 40 minutes on the city roads, and an average of 45 kilometers per hour. So that's going to be equal to her speed times her time, which is 2/3 of an hour. So now the hours cancel out. And we'll have 45 times 2, which is 90 over 3. That's going to be 30. And what's the unit left over? Kilometers. So she goes 30 kilometers on the city roads. So her total distance is distance on the city roads plus the distance on highway. Well, we know her total distance, that's 59 kilometers. We know the distance she spends on the city roads, that's 30 kilometers. So we can rearrange and get her distance on the highway. So that's 59 kilometers minus 30 kilometers, and that gives us a total of 29 kilometers. Okay. So, now we want the speed on the highway. So speed is distance over time. So that's going to be 29 kilometers. That's the distance she spent on the highway. Over the time she spent on the highway, that was a third of an hour. Okay, that was the 20 minutes. 20 minutes spent on the highway. Okay. So now we just rearrange. This is just going to be the same as 3 times 29. And you'll get kilometers per hour. And 3 times 29 is 87. No shame if you need to get your calculator. In fact, I'm even going to double check because you don't really, the 29 times tables don't come up very often. But I tend to think of it as 3 times 30 and then subtract a 3 off of that. So 90 minus 3. A lot easier to do. But I do still get 87 if I punch it in on my calculator. So her speed on the highway is 87 kilometers an hour. Now let's check, is that one of the answers? And there it is. It's right in the middle for us. It's C. Okay. So we bubble in C, and we move right along to question number 24. Thank you guys for watching, and we'll take a look at question number 24 in the next video. So long for now.